In question 72, we're told that in a monohybrid cross, two heterozygotes were allowed to mate and the resulting offspring ratio was 2:1 phenotypically. Okay, so that's our goal, an offspring ratio of 2:1 phenotypically, and we're asked which of the following three explanations could explain that ratio. Well, before we get to the explanations, let's think about what we'd expect from a heterozygote cross. At this point, we should expect to know that we'd have a homozygous dominant and a homozygous recessive and two heterozygous. So the genotype would be 25% homozygous dominant, 50% heterozygote, 25% homozygous recessive. That's a 1:2:1 ratio, genotypically. Moving on to the phenotypes, we would have 75% dominant and only 25% recessive, since you need to have homozygous recessive for any recessive alleles to present phenotypically. So that's a 3:1 phenotype ratio. We want to get 2:1. Well, how can we do that? Let's have a look at the potential answers. Number one, the number of offspring was small. That certainly could be the case, because particularly if the number of offspring was smaller than 4, you wouldn't expect to get a manifestation of every potential genotype. And these numbers are intended to be interpreted in larger samples systemically rather than at the level of individual families. So we can say this certainly could be the answer. Moving on to 2, the recessive condition was lethal prior to birth. Well, let's think about that. If we were to have the recessive condition lethal before birth, then we would only have dominant left over, because we'd get rid of all of our 25% recessive, leaving 100% dominant, and that is in a 2:1 ratio. That's even further away. So that's not what we're looking for. And number 3, being homozygous dominant was lethal before birth. Okay, let's think about that again. If we were to get rid of our homozygous dominant, then we'd have a 2:1 ratio genotypically, since we've got rid of this one homozygote, and we would have a 2:1 ratio phenotypically, because our 75% dominant would be reduced to 50 after losing this proportion. So the phenotypes would have to scale up to 66 to 33%, i.e. 2:1. So this certainly could be the answer, and if this phenomenon persisted at the level of many individuals, then you might believe this to be the actual answer. Anyway, since 1 and 3 are potential solutions, our answer is going to be F.